Good evening. So today I'm going to continue the plastic cladding problem that has been left over from last class. This is for sensitivity analysis. So in this example, a manufacturer produces two types of plastic cladding. They are Encaler or Encolor and Bakelite. And this table summarizes the given information such as resource requirements and resource availability and the selling price. So for example, 1 yard of Encolor requires 8 pounds of polyamine and 2.5 pounds of diurethane and 2 pounds of monomers, and so on. Okay? And an alternative, an alternate method could produce both plastic claddings up to 12 times 750, which is 9,000 pounds. Okay? And we'd like to maximize the total profit. And this is the complete LP formulation for this problem. And this is what I've obtained from Lindell. And I believe we need to answer question number 7, right? Okay. So, how will the decision to purchase 2,000 pounds of additional polyamine change the quantity of diurethane used during the next planning periods? And last time we have learned purchasing 2,000 pounds of additional polyamine is equivalent to decreasing the slack variable for that constraint. I believe the row number 2, right? So the purchasing 2,000 pounds of additional polyamine is equal to decrease the slack variable 2 by 2,000 pounds, right? Okay, and then we need to look at the substitution rate. And just remind you, the substitution rate alpha ij represents how much the basic variable xi decreases as non-basic variable xj increases, right? And the slack variable 2 is the amount of polyamine unused, right? What about slack number 3? That is the amount of diurethane unused. Okay? And according to the substitution rate of slack 2, for slack number 3 is negative 0.1. Okay? So how would you conclude? You remember this negative sign in substitution rates means the slack number 3 would change in the same direction as slack number 2. Okay? So as slack number 2 increases 1, the basic variable which is slack number 3, increases 0.1 or decreases negative 0.1, which is the same, right? So if the company, well, if the slack number 2 decreases 2,000, then the basic variable slack 3 decreases 2,000 times 0.1, right? Which is decreases 200. So if the company purchased 2,000 pounds of polyamine, additional polyamine, it would indicate an additional 200 pounds of the urethane is purchased. Okay? Questions? Okay, then what about number 8? If the profit contribution from Bestlight were to decrease to $11 per yard, will the optimal solution change? So what Lindo output you need to use to answer this question? Objective coefficient ranges, right? Here, the profit of Bestlight has been changed to $11 per yard from $20 per yard, which is a decrease of $9, right? The objective coefficient of the variable B. So we need to look at the objective coefficient ranges. According to the Lindo output, the allowable decrease for variable B is 7.5, right? Which means the basis will be changed. Okay? So if the profit of Bestlight were to $11 per yard, the production of Bestlight should decrease, right? Because the unit profit of Bestlight has been decreased. Okay, what about number 9? If the profit contribution from Encaler were to increase to $15 per yard, will the optimal solution change? This is very similar question, right? So the profit of Encaler has been changed to $15 from $10 per yard. There is an increase of $5, right? So again, we need to look at the objective coefficient ranges for variable A. The allowable increase range for variable A is 6. And $5 of increase is less than this allowable range, increase range, which is 6. Which means the basis will not change at all, right? So if the profit of Encaler were to $15 per yard, the company should still produce 3,000 yards of Encaler and 5,600 yards of Bakelite, right? Which is the current optimal solution value. Okay, next, number 10. That is the last question. So suppose that the company could deliver 1,000 yards less than the contracted amount of Encaler by paying a penalty of $5 per yard shortage. Then should they do this? So which Lindo output should we use to answer this question? First, we need to look at the dual price. What is that? That is the amount by which the objective would be improved given a unit increase in the right-hand side value of the constraint. So this dual price tells you how much you should be willing to pay for an additional units of a resource. Okay? So according to Lindo output, we have a value of -6 for row number 6. Okay? Because row number 6 represents the restriction for contract of A and Encaler, right? So this means for an additional right-hand side value, the objective function value will be increased by -6, which means decreased by 6. Okay? So the company would be willing to pay up to $6 for a shortage amount of delivery. Is that correct? So you are following me? I said the row number 6 is the requirement for contract, right? So by introducing surplus variable at this time, because we have greater than equal sign, right? We will obtain the equality constraint, -6 equals 3,000. Is that right? What is slack 6? There is an excess amount of delivery, right? And in the optimal solution, slack 6 has a value of 0. Okay? I'm sorry, the surplus 6 has value of 0. And if you deliver one more than the contracted amount, the excess amount of delivery becomes 1, right? That is, slack 6 is increased by 1. Okay? So we have A minus surplus 6 plus 1 equals 3,000. Okay? And this is same as A minus surplus 6 equals 3,000 minus 1. Okay? I just move positive 1 to the right-hand side. Which means delivering excess amounts means decreasing the right-hand side value. Okay? In other words, delivering less amounts than the contract means increasing the right-hand side value. Okay? So, if the company deliver 1,000 yards less than the contracted amount of Enkehler, this is same as increasing the right-hand side value by 1,000. Okay? And according to the dual price for rule number 6, which is -6, which means for an additional right-hand side value, the objective function value will be increased by -6 or decreased by 6. Okay? So the company would be willing to pay up to $6 for an additional right-hand side value, or for a shortage amount of delivery that is the same. Okay? So what is your answer? They should do it, right? Because the net change in the profit would be positive. Okay? Okay, so any questions? Okay, then these are the topics that we have covered during this semester. We've learned about basics of LP modeling with optimization solvers like Lindo and Lingo, right? And simplex algorithm for solving LP has been studied by both tabular form and graphical method. And as a streamlined version of ordinary simplex algorithm, we have talked about the revised simplex algorithm, right? And finally, duality and sensitivity analysis has been covered. And especially I've spent such a long time for sensitivity analysis part because personally I think it's very important. However, it's not that easy to perform. That's why I've tried to provide you lots of in-class exercise problems for sensitivity analysis. So hopefully by this time you feel very comfortable with not only sensitivity analysis but also all the other topics. And it could help you for your own research in the near future. And I'd like to thank all of you for your time and effort with IE 533 class. Okay? Hope to see you again soon. Thank you. Bye.